three polynomials. So just as numbers are the big building blocks of arithmetic, polynomials are the building blocks of algebra. This is where we start dealing with variables and x. So in later grades, we're going to use polynomials to model real-world situations for business, science, medicine, engineering, all types of real-world stuff, even construction. So then we talk about the skills and understanding and language that we learn in this unit are going to be our foundation to keep us going for the next few years, okay? This is one of our base units for high school that we really need to understand. So let's talk about polynomials. We need to model what the heck they are. We need to know what they are. So first of all, what is a polynomial? Well, a polynomial is one term or the sum or difference of terms whose variables have whole number exponents. Okay? Take a moment and write that down. So our next definition is terms. What are they? They are the numbers, variables, or the product of numbers and variables. Now, product means that they're multiplied or sitting side by side, because side by side means multiply. So if I've got a 4x, that's actually 4 times x. That would be a term.
Making sure.
Our third definition is coefficient.
There you
A coefficient is the numerical factor of a term. And what that actually means is the number in front of any variable. That's what a coefficient is. The prefix co, C-O, co, that means in front. Okay, so a coefficient is a number in front of a variable. Here's an example of a polynomial. We've got 3x squared subtract 4x plus 2. The coefficients are numbers in front. So a 3 and a negative 4 are coefficients because they are numbers in front of variables. Okay? Well, it's a subtract sign, but it also means plus and negative, right? So that sign belongs to the 4. Okay? This is where we're going to talk about specific things. We have also the word a degree of a polynomial. What does degree of a polynomial mean? Well, if we take a look on the left here, a degree of a polynomial is talking about the greatest or largest exponent on a variable. That's called your degree of the variable. Okay? So if we take a look at the one on the very bottom here, I've got an example that has an exponent 2. And what's the hiding exponent on the end? It's a 1. Good. Don't forget they have hiding 1s. So the largest exponent is called the largest degree. So this would be called a degree 2 polynomial. Okay? Because the 2 is the largest exponent in the polynomial. Then when we take a look at constants, we need to know what the word constant means. Constant is any digit without a variable. So it doesn't have a variable. And therefore, because it doesn't have a variable, only variables get degrees. So if it doesn't have a degree, a variable, it's considered a degree of 0. So the number 6 right here doesn't have a variable, so it's considered a degree 0. This one is telling us the term negative 4n has a degree 1, like I show you here, because the 1 is hiding. Okay? Let's take a look at the next examples. We're going to figure out what these are going to talk about. So what we have to do is we're going to analyze. We're analyzing these, which means we're trying to break them down into specific categories. So, how many terms? Well, first of all, terms are separated by plus and subtract signs. So how many terms do we have on the left of the first one there? 2. Good. There's 2 terms. Okay? On the one below it, how many terms do you have? 3. Okay, we've got 3 terms. What about the one underneath that one? 1, 2, 3 terms. Here's my first one. Here's my second one. There's my third one. The very bottom one, how many terms? 0. We have 3. 1, 2, 3. The terms, remember, are separated by positive and negative signs. So the first thing you do is you find your positive and negative signs. What's in front of it? What's behind it? And you count them. On example 2, 3x squared is 1 term, 4x is 1 term, and the negative 8 is 1 term. 3 terms. Listing the terms, we separate them with commas. So our first term on the first one is 5b cubed, comma. The second term is -7. Okay, the sign in front of the digit goes with it. The next one, I have a 3x squared, that is my first term. My second term is a 4x, and it's positive. And the last term is a -8. Okay? The sign in front goes with it. If it's a positive sign, you don't have to show it, unless you're connecting them side by side without commas. If you're connecting them side by side without commas, you need to put the positive signs in. On the third one here, the first term is a -4n exponent 5. The second term is a 6n exponent 4. And the last term is a -7n. Okay, I ran out of room there. I just wrote into the next part. We take a look at the last one. Our very last one. We have z squared is our first term. We have a 3z, our second term. And our last term is a -9. Okay, so 3 terms. Now what we want to do is we want to find the degree. So when we look at degree, we're finding the largest exponent. So let's find the largest exponent. Over here, I have a large exponent 3. Does the 7 have a degree? Well, it does, but what is it?
2.
0. Remember, only variables get degrees. If it doesn't have a variable, so no variable, 0 degree. So 7 has a degree 0. So which one's bigger, 3 or 0? 3. Good. So he is a degree 3. Okay? Let's look at the next one. The next one has exponent 2, and it's got a hidden exponent 1, and on the 8 is a degree 0. So who's biggest? The 2. So this one is a degree 2. If we look at our very last one, on the third example, we've got a 5, we've got a 4, and we have a hidden 1. Who is larger, 5, 4, or 1? 5 is the largest. So this one is a degree 5. If we look at our last example, we have degrees 2, a hidden 1, and again a 0, because no variable. So what's our largest in that one? 2, degree 2. Now we want the constant. Now this is what a constant is. The constant has no variable. So the way I remember it is I always say the constant is constantly lonely. He's lonely because there's no variables attached to him. So who's a constant in the first example? -7. Well done. Take the sign with him. What is the constant in the second example? -8. Good. What about the third example?
-7.
There isn't one. So we would write none. There isn't one. Okay, because all of them have a variable n.
Oh, you wouldn't write 0?
No, we don't write 0.
Oh, I don't have a eraser.
Okay. Okay. Now we look at the next one. Which one is our constant in the last example? The -9 is our constant. Good. Now, if variables have a certain number of terms, they get special names. Just like when we have an exponent 2, we call it squared. It's got a special name. Exponent 3, we call it cubed. It gets a special name. Well, polynomials with 1 term have a special name, 2 term have a special name, and 3 terms have a special name. Anything that has more than 3 terms, you just state the number. So if it's got 5 terms, you would say it's a 5-term polynomial. Okay? So if we take a look at a monomial, monomials have 1 term. So let's write some examples of monomials. 5 all by itself, 7x all by itself, -15w all by itself. Okay, those are monomials because they're not connected by positive or negative signs to anything else. They're by themselves. Okay, those are examples.
Okay, so
Binomials, the prefix bi meaning by, that means 2. So this one's going to have 2 terms. So they're going to be separated by a positive or negative sign. So this example, we could have an example that had 5 minus 3x. We could have an x squared plus 4. Those are all binomials because there's two terms. Trinomial, just like the first three letters tell us, tri, like triangle, mean three sides. So trinomial, three terms. So anything that's separated again by plus and negative signs, they have to have three of them. So I can have a y plus a 2x minus a 4z. There's three terms. Okay? Doesn't matter if they have different variables. They're still different terms, and there's three of them. They're connected by positive and subtract signs. I could have 1/2 w minus 9q plus 12x. Again, three terms. It means it's a trinomial. This is saying that to us, our very last question here is talking about a polynomial, pardon me, that was hard to say today. A polynomial is usually always written in descending order. Now, descending order means that it's going from the largest to smallest, okay? Now, again, that's talking degree, so it's exponents that they're talking about. So it must be written in descending order, big to small. And the exponents are the ones that tell you what order they go in. So if I check my exponents here, the a has a hiding 1, this guy has a 2, and this guy has no variable, he's my constant. Constants always go last, okay? So we're going to start this one. We have to put the 2 first, 2a squared. The next one's going to be our 3a. Now what kind of 3a is it? It's a positive 3a. Okay, and if they start an expression, you don't have to show the plus sign. It's a hiding plus sign if they start an expression. But if you're connecting them to something else and they're not starting the expression, you must connect them with the plus sign. Otherwise, it means they're sitting side by side, which means multiply. And that's not what's happening. Then I put my 4 on the end. And again, it's a plus 4, so I have to connect with my plus sign. So now this one's written in the proper order, descending meaning biggest exponent to smallest exponent. So I've got my 2, then my 1, then my no variable, my constant. Okay, that's how they're written. You try the next two. Okay, taking a look at what we have here. If you noticed, the 9 is the largest exponent, so the 2r exponent 9 must go first. So I put 2r exponent 9. Then I look at the second biggest one, and it's an 8. So I need to attach the negative 4r8 beside him. My last one, the smallest one, is the 3. He will go last on the very end. So we have a plus 6r cubed on the end. Okay, on this one, the next one, we have a 5 that goes first. So b exponent 5. Then we've got a 3, who's second biggest, positive b exponent 3. Then we've got a b with a hidden exponent 1 that will go next. And he's a negative, so we're going to go subtract b exponent 1. And our very last ones are constant. The positive one is a constant, and the constants always go at the very end. So we put our plus 1 on the very end. Check your work. Our last example here, we need to know what makes a possible polynomial. There are certain things that cannot be polynomials ever, ever, ever. Everything else is always a polynomial. Now let's see what cannot be a polynomial. If you've got a variable on the bottom of a fraction, it doesn't get the special name polynomial. Does it happen? Absolutely. Last chapter, in our very first unit actually with exponents, we saw all kinds of them. We had 7, x5 over 14, x7. We had all kinds of variables on the bottom. It just doesn't get the special name called polynomial. It still exists. Okay? So to get the special name polynomial, we cannot have a variable on the bottom of a fraction. Also, last time, if there's a variable with an odd number exponent on it, under a square root sign. So right now, that's an x exponent 1 under a square root sign. That is not a polynomial. It doesn't get a special name. Now, if it was root x to the 4, you bet that's a polynomial. Root x squared, you bet it's a polynomial. How come? Because the number that's the exponent is an even number. If it's an even number, it's okay. But if it's an odd number, it is not a polynomial. Okay? That is the rule. Okay, this concludes lesson 1 of Polynomials, Unit 3.